Alright, quick. Who are the three greatest and most influential physicists who ever lived? Isaac Newton, Albert Einstein, and... It's okay if you couldn't think of a third one. Not a lot of people could. But most physicists would probably agree that a lot of modern physics owes more to a man named James Clerk Maxwell than to anyone else who ever lived. Maxwell was born in 1831 in Edinburgh, Scotland, to a wealthy Scottish family. He published his first academic paper, a new method of mechanically plotting mathematical curves using a piece of twine, at the age of 14. So yeah, he was an early bloomer. By age 25, he was appointed chair of natural philosophy at University of Aberdeen, natural philosophy being what they called physics back then, meaning that he wasn't just a professor, he was the head of the entire department at 25. Within the next couple of years, he made a discovery that you probably learned about in grade school. He showed that Saturn's rings were made of small particles swirling around the planet together. Before this, nobody had any idea what the rings of Saturn were made of. Scientists thought they might have been solid, but if they were, then the rings should have been banging into each other or even into the planet. And if they were a liquid, why wouldn't they break apart? Well, using math, Maxwell showed that the only way the rings of Saturn could remain relatively stable was if they were made of lots and lots of tiny particles, each one acting as an independent satellite orbiting the planet. All the tiny satellites in the same ring had to be moving in the same direction and at the same speed, or else they would crash into each other and the whole system would fly apart. Maxwell also predicted that the rings would spread apart gradually until they disappeared because of the effects of Saturn's gravity. And that is happening. But until then, we have rings. More than 100 years later, the Voyager probes would fly by Saturn and send back some pictures proving that he was totally right. In 1860, Maxwell was laid off when his college merged with another college and the other chair of natural philosophy got his job. Can you imagine being the guy who made James Clerk Maxwell redundant? That would be like if two karaoke teams merged together and Ariana Grande got bumped for me. After that, he took a professorship with King's College in London, where he made what scientists like Albert Einstein, Richard Feynman, and Max Planck considered the greatest discovery of the 20th century. He published a set of equations now known as Maxwell's equations, and proved that light, electricity, and magnetism all came from the same force, what we now call the electromagnetic force. This is still the greatest leap forward anyone has ever made in creating a grand unified theory of physics. These days, we know that electricity is what you get when electrons move from one place to another, and magnetism is what you get when electrons spin in the same direction. We also know that light is what you get when electrons move from a higher to a lower energy state. When they do that, they release a photon. All of these are examples of electromagnetic force in action. Basically, it's how electrons shape the world around us. But when Maxwell published his equations, electrons wouldn't be discovered for another 30 years. He figured out that all of these things were connected by observing how magnets could affect currents and currents could affect magnets. He theorized that they were all doing that with electromagnetic waves, which spread out through space from their point of origin, potentially forever. He measured how fast these waves were moving and found that they traveled at the speed of light. And since nothing is as fast as light, that meant electromagnetic waves and light must actually be different forms of the same thing. The idea that energy could travel through space in waves blew away the old Newtonian idea of physics, where gravity was the only thing that could affect objects at a distance. And it paved the way for the development of quantum mechanics, plus like everything Einstein ever did, especially once we started figuring out that subatomic particles were a thing. Without Maxwell's understanding of electromagnetism, there also wouldn't be any radio, television, or microwave ovens. Maxwell, of course, made a lot of other discoveries too. For one thing, he was the founder of the kinetic theory of gases. This theory led to the new field of statistical physics, which introduced probability to the science of very small things and was the precursor to quantum mechanics. And he produced the first color photographs in the world after he realized that the human eye only perceives three colors: red, blue, and green. He created red, blue, and green filtered images and layered them together to make a colored photo of a tartan ribbon. This trichromatic process was the forerunner to all modern color photography. Maxwell died of abdominal cancer in 1879 at the age of 48, but he'd already transformed the field of physics forever. So who knows, if he'd lived another 20 or 30 years, maybe we'd have floating cities and flying cars by now. So thanks to Maxwell, and thank you for watching this episode of SciShow, which was brought to you by our patrons on Patreon. If you want to help support this show, you can go to patreon.com/scishow, and if you just want to keep getting smarter with us, you can go to youtube.com/scishow and subscribe. In the end, the astronauts landed safely, and Margaret Hamilton, a computer scientist who worked for NASA in the 1960s and 70s, was why. Margaret rose through the ranks to eventually become